Good evening, everyone. There you go. Hopefully you have the opportunity to review this scenario. One important thing with patterns, in case you never used it before, or even if you have been using it, patterns are like the Lego blocks for building software. You have a problem, and instead of start working with classes and aggregation, composition, association, and so on, that is kind of the last resource. The first thing in the upper level is, well, this problem can be represented using some kind of the ideas that we have as a patterns. Can we go and talk about something is observing something, meaning some class have information that another class need? Just like in the example that we review, the pattern, the name give you the class diagram. And when you look to the class diagram, the idea is the source code is just translation. Is any programmer that you show this design is going to be able to give you the same solution. And the solution is going to work if the pattern is well implemented. You need to do testing, yes, but you are testing that the implementation was correct. You are not testing if the solution is going to work. The solution works. The only thing that you need to check is that you implement the solution correctly. And those are two different things. The solution versus the implementation of the solution. The capacity of your programmer, your worker, to follow instructions versus these are the instructions that solve the problem, period. So we reviewed Observer. Hopefully you run this, everything is clear. If not, send me an email. Moving forward, assuming that it's clear. The idea with the patterns is they do not work alone. You do not apply one pattern to a system. Your goal when you design software is to create a piece of software that is basically a collection of patterns. So when you look to a class diagram, it's not this collection of classes, boxes with the lines, aggregation, composition, association. But the idea is looking to the class diagram like this is a Lego construction. And here, there, we are using this particular block. And we're combining that one with this other, and all together create whatever system you're designing. I showed you the example of the observer in input, output on the console. Think about it. If I show you this diagram, this is the same that I showed you before, but now I want to include graphical elements. And when I want to include graphical elements, well, I am going to involve new classes. When you have a problem and you have new requirements, your goal is basically select the class that is going to help you to achieve those requirements. If you already have this student, professor, whatever working in the console, and now someone asks you for a graphical version of this, is, well, what do we need to extend the solution, to add more to the solution? You do not need to change everything. It's just adding new things. And doing something graphics is like, for sure, we can use panel. Panel is the core of the graphical elements. Why? Because then we can add the panels to a frame. The frame is the main program, and we are done. If I show you this inheritance here, I think it's pretty clear that what I want to do is, well, now student and tutor, they are going to be panels. So they are going to be graphics, and they are going to be able to be added in some place. Two ideas. Idea number one that I am following with a student is you can do a student a graphical element directly. Student is an observer because the connection with the observer interface. Student is going to be a panel. Student together is both things. An observer because the behavior that the student has, and a panel because it's going to be a graphical element. I can use implementation and I can use inheritance. A second solution. The second solution is, well, you know what? Let's do separation of concerns. A second solution is I create another class. And this new class, whatever, that one is going to be the graphical element. That is going to be the one that inherits from panel. And that one is going to use, or if you want, it can have a tutor, the one that is observable. Everything in one, split in two. My question is, which one is a better solution? Which one would you use? The one that I use for a student or the one that I put for the tutor in this example? In a big system, if really whatever you have here inside is a lot, this is the best solution. This is the good solution. The correct solution according with the book. The one that you follow because that is what the book says. If you have a student that is too small, if you are going to have this one with two methods, if the student do anything, just like in the example that I showed you before, print something, it could be acceptable to follow this solution. Again, you are doing a building, you are doing the house for the dog. You do not follow the same rules. Small system, big system. Small system, one class, two responsibilities. If the class is not too big, it could be okay. I am using the okay. This one, as you mentioned, that is a good solution. Separation of concerns. The graphic thing versus the real thing, the functionality. This is your view. This is your model. Thinking about model view that we're going to talk later. So joining patterns. Anyway, if I want to add the graphical elements and I want to do this diagram, source code, something that I am giving you and I will ask you as a homework to review is, this is the implementation for the new classes. If you notice, the only thing that I change is here. I did something with the student. So I need a new implementation for a student. I did something with tutor and I add a new class tutor panel. So those three things change compared with the previous example. This is my new student that hopefully you can compare with the previous one. And you're going to notice the changes in the source code. Well, obviously, I will keep the implementation of the observer, but now I am going to have in the same class this extend panel. That was the only thing that I did new. Because now this is a panel, I can work things in the constructor, graphical things. I can have pictures, classes from the Java API, an image. I am going to use an image of a student, whatever that is. I am going to add that image in a label and I am going to put the label on the panel. So something is going to appear on the screen that is a picture, and that picture is something related with one student, if that is something that I want to do. Some actions, similar to the previous one, and the method for the observer. The only new thing, because I want to move to the graphical world, is the constructor, the elements that correspond to the graphic part, the extent. Everything else is the same. The version of my system with pictures or in the console do not mix. New methods, new instructions, but everything else continue working. Separation of concerns. If you think about the tutor, this tutor, you can review what is happening here, and everything should be the same. I mean, according with my diagram, I am not doing anything to tutor. Is my tutor class. This is new. This connection is new, but this class should be what I had before. Tutor. This is new. This class I didn't have it before. This one, according with my previous diagram, I am doing some kind of connection. The connection, association, composition, aggregation, you decide. Right now, just because I have that in blue, it's not going to be association. Maybe looks like aggregation. I need to review here what is going to happen. Could be composition. No, it's not composition. Parameter can be null. So according with this implementation, what I am doing right now is my last choice. I have a white diamond there because I decide to make it global instead of a local variable. So aggregation, I aggregate a tutor in the tutor panel instead of just connect them. There is a reason for that, and it's going to be one of the next patterns. But that is the connection. Now, I am connected. I am connected, and therefore, I can use in the panel action listeners for the graphical user interface. And things can happen. And the things that can happen, well, are connected with I can call methods in the tutor. And when I call methods in the tutor, well, basically I am using that class. And by the way, that class is according with this observable. So when I use the panel to do something to this guy, and this guy is being observed by someone here, whatever action I do in the panel happen to this guy, and someone here, maybe this class, is receiving a notification about that action happening. The process is the same that we reviewed before. It doesn't matter that now, somehow, the user uses a graphical user interface to make the changes. And maybe this one now is a graphical user interface, is going to show you something on the screen as a result of this relationship here, the data that happened here, and the reaction that causes here. An observer with a graphical user interface using inheritance. Small changes, nothing change, a new class, one connection. Notice, we use patterns to solve big, complex problems. We search for a pattern to share information between two classes, because sharing information is like, okay, I need to do what? Call the method, send the variable, receive. What can I do? But we do not search for a pattern used to connect tutor panel and tutor. It's like, okay, you want this connected with this because this one is going to use this, or it's going to has this, using, having, is. Those three relationships, we already know them. If we can use those verbs, use, has, or is, a, we just go ahead and use that. But if we need something more complex, like I need to share information, and share information is having, using, inheriting, cannot be solved so directly. Go for a pattern. One of the 23 that we are mentioning now. Observer, the first one. So observer, whatever. The only thing that I need is the main. The main, well, is the guy that is going to have the frame. And as you can imagine, I still need to do all the things that correspond to the observer pattern, add the observers, create the observable, create the observer, connect them. All those things, I need them in the graphics or in the text. But obviously now my main has graphical elements, so I maybe need to do the things in green. I need to set a layout. I need to add the panels. The student, that is a panel itself, because I use inheritance, or the tutor panel, the new class. And for the new class, I am sending as a parameter the tutor, the one that is going to be observed. And obviously, the frame, the size, and make everything to show. The different colors in the code. Imagine that they are the different blocks in a Lego thing. The green ones are the new things that we add for the graphics. The blue and red, what's the thing that we used before to do this observer connection, to connect two blocks, to make a bridge? It's working, should work. And it's going to show you something like this. Two panels in a frame. I can write anything here. I can click here. And the idea is, well, this is the professor is asking a question. The student is observing the professor. This guy is going to receive the question. And the only thing that I am doing right now is, well, this guy is going to print the question in a different panel. I have two panels. And whatever happened in one is showing in the second one. This is so simple, but think of a scenario in which I ask you to have a window with two panels and maybe put here a number, send the number, and plot that number on the screen. And if I send 10 numbers, click OK 10 times, maybe the same number or different numbers. One part of the screen plot things, the other part is receiving the information. What happens if you have not a panel here, but use a class without a graphical representation? Use like your class calculating the TSP problem. And every single time that you calculate a new connection in real time, you show the connection here in the plot. One class can be used doing the calculations. The other class can be used doing the plot. And there is one standard way in which you can do the connection, and it's exactly the same standard way for doing something as trivial as these two guys on the screen. The solution is standard. And the goal is that if you, 100 people, understand the idea with the observer pattern, and if I ask you to solve a problem that involves sharing information between two classes or between two elements, modules, packages inside of a software system, and you apply the pattern, instead of having 100 different solutions, one that could be better than the pattern, but a lot that are not going to be better than the pattern, well, now I am going to have 100 standard solutions, all of them following the same recipe, all of them following the same steps. And if I ask you, what do you prefer? 100 different solutions, one of them could be better than the standard, or 100 standard solutions. I know we are number one in innovation, but in terms of software, the people prefer the standards. The standard is just, this is going to work. The innovation, well, there is a research and development department. You can go there, but for the production department, standard solutions that work. Sorry, makes sense. Now, moving forward, that was only one pattern. There are more. That was one of the complex ones. I want to share you one of the easy ones, just to compare how diverse is this idea of the Lego blocks. Think about it. You have Lego blocks that are so simple, like only one single guy with only one single thing to connect. And you have others that are crazy. And I am not going to draw anything crazy. So that is the same idea with the patterns. You have the observer for classes, the connections, and then suddenly I can show you another pattern that is used. I am going to move from the observer in the behavioral one to one here in the creational one, the singleton. The observer is a behavior. The observer is something that one class is doing with another. Is I am a class, you are a class, and I am observing you. Is my behavior, observing you, right? Now, moving to another classification is creation. And I mentioned this example in the previous lecture is, I want to create what? Objects. That is the only thing that I can create, right? Object-oriented programming. Now, in terms of creation is how many? You want to create several or one? Let me think in the easy option. I want only one. For some kind of reason, from one class, I want that class to have only one object. How many objects you can create for one class? Normally, as many as you want. Anytime that you use the new, you are creating a new object. From what? From one particular class. You can put new, whatever is the name of the class, and voila, you have a new object. What if I only want to allow one object from a particular class to exist? Not yet. Sorry, guys. I mentioned bridge. You like connection between two things, but there is a pattern called bridge, and I am going to talk about that one later. No, not the pattern bridge yet. So the singleton, only one object. What do I need to do to have only one object from one particular class? Well, you can put if conditions in all your program. Standard solution. You know what? You have a class. Like I have this class president. And you know what? I want only one president in the university. One and only one. So I am going to have the class president, but I am only allow one to be created. It's like in my system, I am going to have a conflict if I have two object presidents. Okay, president. This is the pattern. What is the pattern telling me to do? There are no relationships. There are no connections. No. The only thing that the pattern is telling you to do is you only want one president in the system. You want to be sure that only one object president exists. Easy. Inside of your class, you need a private variable, right? Remember the minus? And that private variable is going to be from the type president. You are going to create one object from the same type of the class that you are creating? Yes. In the pattern, the name of the class is singleton, then type for the variable is singleton. In my example, the name of the class is president, and it's going to have an object president. Two options. You can put the name here like an attribute, but hopefully you remember it like you are talking about this one having a global variable from the type. Can be null, is used like this. Okay, good. Second, can I do that? Can I have an object from the same type of the class that I am creating? Is possible? Looks like recursive, but it is possible? Possible, okay, good. Now, moving forward, it's like I am going to need a constructor. Yeah, a constructor, whatever. I need a name for the guy also. The constructor, you know, the signature for the singleton pattern is not the fact that the singleton pattern have this object from the same type of the class. The signature of the singleton pattern, you know that you are using a singleton pattern because one small thing. Did you notice the minus there? Is one of the few times that you're going to show a private method. Moreover, it may be the first time or only time that you're going to notice a private constructor. Usually, they told you the constructors are public because we want others to call the constructor. What happens when you put a constructor private? No one is going to be able to create objects from that class. You put private the constructor and the number of objects from the class, 0. It's the default constructor. Every single time that you try to do new president, in my example, the compiler is going to give you an error. You cannot use the constructor outside of the class. Private, inside of the class is fine. Outside, you cannot. Okay, if I am not going to be able to use the constructor outside of the class, well, maybe what I need to do is, somehow, if this class is going to do something useful, this class needs some kind of public method. Public method, well, if I have a variable here, at least I need a public get for that variable, right? Okay, now what happened if I told you that this is what I want? This is the picture of the diagram. It's like, well, you tell me that the class is singleton. You can change for president in my example. You told me that you need a variable from the same type of the class. That variable, you can use any name. In the pattern instance, it uses the name of the object. Any name is fine. When you have that, it's a variable, it's private. So far, good. Static. What is the meaning of static? Only one, right? A static variable. A static attribute is going to be one for the class. Moreover, constructor, private. Well, if you want to use inheritance with this, let's allow that. You can use protected. You do not need protected, only if you want to have a family below the singleton. If not, private, which means this guy is not going to be called. But you have a method. That method is going to return a singleton. It's going to return an object from the class. It's going to return a president in my example. Why? Well, it's a getter and is a getter for this variable. Therefore, getter for the variable should return the type of the variable. In this case, the same name of the class. Now, the variable is static. The method should be static. Yes. There is one other reason because we need the method static. What do you need to call a method? What do you need to call getInstance? You have two options. Number one, you need an object. Number two, you need the name of the class. And in this case, you know what? I want to use the name of the class. I do not want to have an object singleton or an object president or whatever to be able to access the method. If I want to use the name of the class, I put the name static. And check what is happening inside. The variable that I have is null. If yes, this is the new. That is the one that is creating the object. What happened the next time? The next time is not going to be null because I did the new. Only one time the new is going to happen. Only when it's null, it's going to be execute the new, and it's not going to be null anymore. What happens if it's not null? I return the instance. So, are you telling me that in a program, you are going to do something like public class, the president, and then you're going to have something like private static president X. I don't care about the name. And then you're going to have private the constructor. Whatever the constructor do, maybe nothing, but private. And then you're going to have a public method static because it's going to be connected with that variable static. That is going to return a president, the type of the variable. And it's going to be get something. Get president is a getter. And inside, it's like, well, if X, YX is the name that I put to the variable. If that one is equal to null, the president do not exist. X wait, are you calling the constructor? Yes, but inside of the class, I can do that. It's private for others, but inside of the class, you can use it, right? That is the meaning of private. Okay, so what happens if it's not null? Nothing. And at the end, return X. You can improve this, right? Whatever. Only if it's null, do the new, else, nothing, and doesn't matter the case, return the object. What happened in my program? What happened if I have this class meeting? What happened if I have this class Arizona? And what happened if in the class meeting I need a president? It doesn't matter where we are inside. I can use the name of the class and I can call the method. And this is going to give me access to the president. And if in another class, in another method, in any part of the system, I do the same again, these two in two different classes, two different packages, whatever, both are the same. You can put here, obviously, inside of the class, this one is for the pattern. But here I can store the name, I can store the age, I can store values, X, Y, Z, whatever you want. And then with these two, you can continue calling other methods, get the name, get the age, get the value, whatever. But these two are giving you in any part of the system the same object. It doesn't matter where you need the precedent, you are going to get that one. And it's going to be one and only one object, precedent. Tell me, I am sure that you have used this pattern. If you have worked with any kind of APIs, libraries that handle information, I am sure that more than one time you have found something like the name of the class, get something, and that something represents one instance of the connection with the database, one instance of the connection with some kind of a stream, one instance of some kind of algorithm that you are using. Have you used that one? Any library, not only with Java, but maybe with JavaScript or whatever. And I am sure that you can find something like, this is the name of the class, get, and something here, something that if you think about it is unique. And you're calling this line again and again and again and again to get access to that unique object, because that is the one that maybe build things. Is a factory with Singleton that we're going to talk later, or is the connection with the web, or is the connection with the database, or is something that is a shared resource. When you have something that is a resource that you're sharing with others, instead of worry about the conflict of access, instead of using a lot of conditions to validate things, Singleton solved the problem. You have only one object, only one connection, and anyone that wants to use the connection, the stream, whatever, get access to this one. The pattern is this thing with the name Singleton. Something that I need to be clear here is this is the template, and this Singleton do not need to be the name of the class. I use the name precedent, and I am telling precedent is a Singleton. I implement my class precedent as a Singleton. And you are going to notice that my precedent is a Singleton when you read that I put when you have the constructor and you notice the minus, that is a suggestion that, okay, that guy is going to be unique, only one object from that particular class. In my example, I can create two objects. Try. S1, S2, equal to the instructions that we reviewed before. And you know what? If you do a condition and you ask if 1 is equal to 2, remember, I am using equal, not equals. Do you remember which is the only way in which equal is going to be true between two objects? What I am comparing here with the two equals? What is the difference between the two equals and the equal method? Correct. Can you agree with that, right? If you have two objects, this method equal is the one that you can use to compare that the name is the same name that this one, or the age, or the grade, or whatever, but they are two objects different. These objects have an address. This object have an address. Never, never, never two objects are going to tell you true for this instruction unless you compare the object, like this one is A, this one is B. A equal A is going to tell you true because you're comparing the address. The address of A is the same as the address of A. But the address of B, in this example, if they are two different objects, they have two different addresses. But here, S1, S2, they are references to the same object because you get them from the singleton, and the singleton is always returning only one new and returning the same thing always. Every single call to this get return the same, one object from the class. Good. When do we want a singleton? Well, think about it, and I continue with my example. If I have Canvas, and in Canvas I have quizzes, I have exams, I have, I don't know, whatever I can do there. Sometimes, several times, you are going to need someone that is going to be the manager of the system. Someone that is the one controlling the resources. Someone that is controlling the access to the database. Someone that is controlling the access to the ASU system for your grades. Someone that is the interface for something. Someone that could be, in some cases, the graphical user interface. We're going to talk about it. Every time that you need someone in the system that is one and only one in the real life, that is a hint for you to use the singleton in the source code. In the real life is one, probably you want one in the software. Professor in the classroom can be a singleton. You have only one professor. TAs is a class, maybe zero, maybe more. Student is a class, maybe zero, maybe more. But singleton, the professor, for sure, is going to be one. And that is what you want. Well, if that is the case for the system. Makes sense? Okay, singleton. Next one that I want to explore with you, decorator, but I continue next lecture. Please review the source code, compile and review everything. Good? Okay, guys, see you next lecture. Thank you.